Hello everyone, this is going to be the fourth video of our indexing playlist. In this video, we are going to study about hash indexes. It is 4 a.m. in the morning, I'm feeling a little sleepy, so I'm just going to cover this video a little fast, and I don't think it's a very big topic, so I think you will understand this topic really fast. So let's get started. So first of all, before understanding the hash indexes, we should know what are hash functions. Hash functions are simple function. Let's say this is a function in which, if let's say I'm going to pass Karthik as a string, okay, it is going to give me, let's say, 80. If I pass f lol, it is going to give me, let's say, 10. So every time when I'm going to pass Karthik into my hash function, it is going to give me 18 always. This is the hash function. For the same input, it is going to give me the same output every single time. These are known as the hash functions. They can return the same checksum, they can return the same integer value or any string value, anything, but they are going to give the same value for same inputs. These are known as the hash functions. Now let's see what are our hash indexes. So first of all, I have one school table. In this school table, I have three columns: name, age, and class. After that, I am going to insert some entries into this table. So let's say I am going to insert the first entry, 7, 18, and 2. Now what I am going to do, we are going to put an index on the age column. And in this video, we are covering the hash index. So we are just going to put our hash index on this age column. So what is going to happen this time? When I am going to put a hash index on this column, then this particular 18 is going to be passed in our hash function. So I am going to pass this 18 in our hash function, that is f18, and it will returning a value 2. I'm just assuming that it is returning a value 2. It can return some checksum as well. Let's say again I pass it 28, it is going to return me a value 4. If I pass 60, it is returning me a value 8. And if I pass 28 again, okay, again see, Jordan is having in the second row having the age 28, and again lol student also having the age equals to 28. Then they both are going to pass into hash function and return the value equals to 4. This is known as our hash functions. And what is happening when we are going to insert this 18, this age columns values are going to be passed into our hash function, and they are going to give some desired results. What we are going to do when these values are going to be passed from the hash functions, when we get the result, we are going to store into an array. Let's say into an array, or you can say we can store into in some sort of a map. This map is going to be in our RAM, or you can say in memory. So now we came to know that hash indexes are going to take place in our RAM, or you can say in memory. But previously when we were studying about the B trees and B plus trees, they are going to store the data. Now you know now that when we are going to make our index table with the help of B trees and B plus tree, we are making a separate table into a disk. Okay, and then with the help of the B trees and B plus tree, when we are doing a read operation, we are taking log n time. But when we are using a hash functions and when we are using the hash indexes, they are into a RAM that is very fast. Secondly, the operation in the hash indexes, the read operation in our hash indexes is going to be O of 1. Now we know two things. Hashing is faster than B tree. Hash index is of course faster than B tree. Okay, this is something that we figure out because B tree is going to take a log n time and hash index is going to take O1 of time. Plus, let's talk about the writing as well. In B tree, when you have to write something, so what is going to happen when you are going to insert something into our database, or you let's say in our table, then this data is also going to be written into my B trees, because when we are studying B trees and B plus tree, that writing is also going to take log n time. But in the case of hash indexes, it is going to take O1 time. So reading is also faster and writing is also faster. The data is going to be stored in RAM. That's why hash indexes are pretty fast. Now let's see how they are going to store the data into a simple array, or like let's say in our map. This is our RAM, and in which let's say I am just assuming that there are 8 indexes. In that, let's say I'm just getting the value of f18 equals to 2. Okay, so I will just store the value in front of 2. I am storing that for the first row we have this data. Okay, for the f28, what I am going to do, f28 for the second row, I just got the value 4. So in the fourth index, I just put the second row. After that, and f60, I am getting the 8th row. So I just put the third row is going to be in the 8th column. And in the 4th row, what I am going to do, I am just going to make one linked list over it. So this is my 4th index. This is my second row entry. and after that I just make a one more linked list here, that is our fourth entry. So in easy words, we can also say that whenever there is going to be hash collision, we are going to make a linked list over it, and the problem is going to be sorted. So the question arises is, if the hash indexes are pretty fast and taking over time in writes, why we are still using B trees and B plus trees as default indexes? Why we are not moving to hash indexes? There are 2-3 reasons. Let's discuss them. First reason is going to be RAM. RAMs are very expensive. RAMs are pretty fast, we know that, but they are going to be very expensive. As our data is going to increase, we have to take more GB of RAMs, and we have to pay a lot of money for that. For speed, we have to pay a lot of money in RAM. This is the first problem. Second problem is, with the help of the B trees and B plus tree, we can solve the problem of range queries, because data is always sorted. Data is always into the sorted order, but in the hash functions, the problem is the data is not sorted. It is very good with normal queries, but it cannot solve the range queries. So let's take a simple example. Let's say select star from student where username equals to savage. In that case, what is happening? Hash indexes are going to work faster than our B trees or B plus tree indexing. But the only problem, let's say select star from student, okay, where age is less than 10 and age is greater than let's say 6. In that case, B tree and B plus trees are going to work awesome, but our hash indexes will fail. Okay, so these are the reasons why we are using B trees and B plus trees, our default indexes. But the only problem with the B trees and B plus trees that we know is going to be that they are going to take log n of time, and hash indexes are going to take O of time, but still we use B trees and B plus trees as our default indexes. So, but in some cases, where are some specific query, let's say select star from email or select star from username, in that cases, we can go to our hash indexes. Otherwise, we always go to B trees and B plus tree in default indexes. So this is all about our hash indexes. So in the next video, we are going to study about bitmap indexing. It is also an interesting topic. It was discovered by Oracle. Let's see in our next video. So thank you for watching me, and bye bye.